My name is Dustin Vannoy, and I'm a data engineer, which is good because we're on the data engineer track. So the kind of stuff we're talking about, a lot of it I'm working with on a regular basis, day to day. And I hope that some of the experience I've had and some of the things I've had the chance to see will be beneficial to you all. So you've probably heard this a couple times already. Be respectful to everyone, both by silencing cell phones and every other way you can think of. Plenty of stuff to check out at PASS, so don't forget to do all that. If you want to see the slides I'm going to show, at the end I have a reference of a bunch of other sessions that by reading the abstract look like they're useful for this kind of discussion if you want to go deeper. Check out dustinvannoy.com or go to my Twitter handle, Dustin Vannoy. Anything Dustin Vannoy I have, no one else seemed to claim all that stuff. What I'm about is modern data systems. So I do data engineering consulting. I started my career as a business intelligence consultant in the business objects and SSIS and SQL Server space. Worked for three different companies since then, and about 6 months ago went back to consulting, doing much more modern Spark, Python, streaming with Azure and AWS type of work. So I love talking about the cloud. I love talking about data lakes. I've talked about data warehouses for a long time, so I have a lot of the somewhat old school thinking, but trying to adapt it to the cloud. So I hope that that experience will help you all see that, hey, if I can make a transition from not knowing Python and not knowing Spark to doing that, if you're in that journey, that you can do it too. So this is part of the Azure Data Engineer pathway. I hope that you know this. I hope that you saw Jess's session this morning, which was really great to set everything up and kind of give us a good overview of the roles and responsibilities. Obviously, we'll be talking in this session about where that data lives when we're doing analytics in Azure. So we're going to talk about storage options, which is mostly where the data lives and what our options are for that, but also how we're going to access that data once it's there. I would love to talk a lot more about Azure Databricks than I'm going to, but Simon's going to be talking about the ETL toolkit, which will cover some Azure Databricks and some Azure Data Factory, and I forget what else, so that'll be a really good session tomorrow at 3:15. Right before that, by the way, Ike, Simon, and I are teaming up for 10 cool things about Azure Databricks. So if you like what you see with Azure Databricks, want to see more, or you're using it and think maybe we figured something out that you haven't had a chance to do in your own environment, come check it out, ask some good questions, it'll be fun. And then finally, Ike on Friday at 9:30 a.m. is finishing off the track with data modeling trends for 2019 and beyond. So this session, we're covering 3 things, though the third one's going to be pretty short. The first 2 are data lakes and data warehouses. So now I'm going to ask you to interact really briefly, and then I'll leave you alone, and you can do what you need to do. So I want to see a show of hands who feels like you could describe to someone else what a data lake is. OK, I'm thinking close to half. That's good. That's good. Who could describe what a data warehouse is to someone? All right, I see a lot of those. OK, cool. So I will make sure I spend a little time explaining what a data lake is, try and let you know when I'm bringing my own bias to the table, and it's not maybe a standard definition. I don't know if we really have standard definitions anymore. But I'll let you know when it's my bias, and I'll try and convince you. And we can talk about it over drinks at the reception or something if you disagree. I'd love to hear feedback on that. Analytics, we're really going to look at just a couple of ways to access this data that are pretty common in Azure, just to kind of complete the picture. So hopefully that's what you expect to be getting out of this. We'll talk a lot about data lakes and data warehouse, but we will be talking about the storage options for those, including the different types of databases like Hyperscale. That was an amazing demo this morning. My demo is less amazing because I'm paying for all the usage, and I did not want to do petabytes in Hyperscale. All right, so Azure data lakes in Azure, the first thing we need to do is define a data lake. This is my definition. Heavily influenced, of course, by many people, but also made up by me. So varied data is a key to a data lake, in my opinion. If someone says we put all our raw data in the data lake, some kind of distributed file system like Azure Blob Storage, S3, HDFS, we'll talk about some of those things soon. I go, OK, cool, that's fine. But if you're going to say you want to build a data lake, I'm going to encourage you to put some of that partially processed and even some fully processed data in there so that people don't have to go to a data warehouse to get data out of a data lake all the time. And what that's going to do is going to shift some of your load over to that data lake, and it's going to get some people that maybe some data scientists that prefer Python over SQL, they're going to be bugging you about how they can access the data, and you go, it's right here in the data lake. You're using all the tools that work well with these data lakes we're building. Go straight to it if you want. We'll talk a lot more about that as we go through. It's ready for analysts, and so anytime someone puts data in distributed storage and doesn't do any work to at least suggest a template for how people will access that data at their organization, doesn't do any planning on how we're going to give people access to data, and we don't have a way for them to go, I need this type of data, hook me up to the data lake. That should be something we're prepared and ready to do, and probably we should be doing some training and consulting within our organizations about it. Finally, which means it's not just a file system. Finally, it's big data capable. This, you might be able to argue this one a little bit, but basically we're going to follow the approach of storing a lot of data, store it first, ask questions later. So going a little deeper on that note, do you guys know the story of where the data lake term came from? All right, no one's responding, so I'm going to go with it. James Dixon from Pentaho, at least this is what Stacia Varga said on a podcast that was really good. James Dixon came up with it as the data warehouse, the data marts in your data warehouse are like a bottled water. It's like refined, ready to go, packaged, not going to get in too much trouble with it. At least that's my interpretation. Whereas the data lake is where this raw stuff comes streaming in. You have all these ways to access it. You might dive right in. You might just take a sample. I don't know, you take this metaphor and go crazy with it, but that's the idea. I resisted the term for about 2 years until I had to give in to the industry's new big term. So one day we'll replace it with something else I like better. But for now, I'm all about data lakes. So I'm going to talk 3 reasons why. Reason number 1 for data lakes is to store everything. This world we live in, there is too much data to put the new data sources in a backlog, take your time to think about it, model it, clean it, before you start to capture it and store it for future use. I would also argue you probably have more data than you're ever going to get to in your backlog, and we need to develop a way that different teams can contribute to a common data repository. Different teams can pull back out from it and hopefully contribute back. And we start to get to this world where we don't care if we have way too much data to ever deal with. One day we're going to need some of that data. We don't know which. We're going to have multiple tools to deal with it, and we're going to figure out the schema, figure out the ugliness of the data when it's time to use it. That doesn't mean you abandon everything else, which we'll talk about, but it does mean we're starting to have a place to put data, no questions asked, kind of. No questions asked except security and that kind of stuff. Schema on write comes with that, and then we're talking about cheaper storage options because I just said we don't want to think about cost. So if you don't want to think about cost, you better make it cheap. Or spend a lot of money on compute, which we'll probably end up doing, and then no one cares about the storage cost. So reason number 2 is massive scale. We are kind of in this world of serverless Hadoop. I don't know if that means something else, but what I mean by that is we kind of talk about Hadoop being dead, and we put blog posts with the title Hadoop is dead, and yet we go and use the Hadoop API all the time to access S3, Azure Blob Storage, and the things we're going to talk about today as distributed file systems. So we've moved this model of Hadoop. We'll talk a little bit more about it. It's okay if you aren't super familiar with Hadoop. You probably don't want to go too deep on that path at this point. But we've kind of moved to where all these cloud systems are providing the functionality that Hadoop gave us. And we've taken that model, the MapReduce model, we've made it better. We've now can do it 20 different ways and listen to 20 different vendors tell us why theirs is so much better than everyone else's. But we're going to focus on Azure, so it makes it a little easier. We don't have to compare everything under the sun today. One of the cool things about the way we're going to try and do massive scale is we're going to want to have hot and cold storage. Again, cost savings. We want to store a whole lot of data. If we don't think we're going to use it, we put it in some cool storage or archive storage. Expect to never touch it, but we keep it because when that big question comes along, we need to answer it. And then, ideally, we're paying for what we use because of the scale of the data. We're paying only for what we store, not for a bunch of disks that we're not using, and we're paying compute for what we need to process, not for all the storage that we have sitting around not being used. So reason number 3, I may have touched on this because I always talk about this, is the separation of storage and compute. This is why I'm super hyped about hyperscale as well. We'll talk about that. But we're trying to get cost savings, and we're trying to allow people to use their own tools, the things that they like to use and interact with data, to access it. Many in your organization may want to use SQL, and that's great. I've been learning lately as I talk to people about the ways I typically set up data lakes and data warehousing systems. And sometimes they're like, well, they just want to use Python. I'm like, oh yeah, the things have changed. Not everyone wants to use SQL anymore for analytics and data science. So we're going to find that we can store the data once in these distributed file system data lakes, and we can access it, the same data with a whole bunch of different tools. which is crazy, but it's a huge benefit over having to store it on all these high-cost servers, right? So with that, I figured we should look at what it looks like to query a data lake. How many people have queried it? A little more interaction, sorry, but how many people have queried a data lake before? All right, cool. How many people have written SQL before? Yeah, all right, so this is gonna look like what's this guy showing us. This is just SQL, and that's what I want you to get from this. But it is going against files, and I'll talk about that as we go. My demos are live, so wish me luck, and I apologize for a little lag when we switch over. And especially if it doesn't connect, and then I have some backup plans, but they're not nearly as fun. So this is an Azure Databricks workspace. Azure Databricks is a managed, unified analytics platform is the marketing speak. It is tools for analytics built on Apache Spark. The people that created Apache Spark, some of the people that created Apache Spark founded Azure Databricks, or founded Databricks. Azure and Databricks have partnered. First-class service, easy to spin up, easy to spin down, really powerful. The thing to know about Spark and Databricks, which is also the thing to know about Hadoop if you're not familiar, is that it is a clustered, distributed, clustered computing environment. Spark is pretty general purpose. It has a few different ways of interacting with data, but it can work in streaming, it can work in batch, all kinds of stuff I'd love to share with you, but we're gonna talk more about storage and what a data lake is. The other thing to know that cluster computing usually indicates is that we can scale horizontally. So I start off, I have like 2 worker nodes that all these tasks are gonna be running in parallel across 2 nodes, right? So there's stuff happening behind the scenes that I don't even know about unless I look closely. I can easily scale up to 4, 6, 8. I don't know about easy, but you can get to like 100, more than 100 nodes in my cluster as my data grows, as my processing grows. I can scale back down throughout the day as well. And Databricks brings us this auto-scaling capability, which I mentioned because that's another thing you want out of a data lake. You probably want it out of everything, but you may not get it except in your data lake. So when you're looking at data lake technology, you want to be able to auto-scale if possible. All right, without further ado, let's query these files. So I'm cheating a little bit, I guess. I'm going to show you the setup later, but initially I'm going to query a table that I've already created as an Azure Databricks table. So I've switched over to an Azure Databricks notebook, and you can see you can do some markup things to document here. I'm going to do a quick query of the million-song data set because it comes with your Azure Databricks workspace. You can just connect to one that Databricks hosts. So I figured we'd start with something that you can do probably right now if you really want to. I guess you have to take 5 minutes to spin up a cluster, so you may not be able to. But once I get to, I can do a select count, no big surprise there. So we're working with 500,000 records out of our million songs. And then once I want to write a query statement that I just realized, I should probably zoom in, huh? In the back, can you see? Barely, okay, that's what I need to hear. Come on. In the back, can you see? Slightly? Okay, we'll go with it. So this, in this cell right here, let me get it centered for you at the very top. I'm going to run a query that is basically a group by, average, and count. Nothing groundbreaking, but the cool thing about it is I've created this Spark managed table with Databricks pretty easily. I'll show you in a moment. And it is in Azure Blob Storage. The first time you run one of these in each notebook, I tried to warm it up for us. I don't think it worked. It has to set up this context that it then keeps for the whole session. So that'll finish soon. But this actually is a good example of, I want it to be like 3 seconds, and I was going to tell you this, but we'll go with, it's going to be like 20 seconds or something. So with these data lake environments, you probably aren't talking about run this query and get immediate feedback and don't have any time where you're sitting there going, come on, give me my data. But a lot of times you can run queries, at least ones where the data is prepped and formatted correctly, and get results before you have time to go get a cup of coffee, which is better than Hive on top of Hadoop, at least in most of my experience. And so what we're seeing is we probably get a little bit slower performance than we could out of a relational database in some of these cases, but we aren't storing all of our data in a relational database. So there's some trade-offs, of course, that will keep coming up throughout this conversation. But when I see a query response come in like 3 seconds and I'm storing it in Blob Storage, I love it because I know that the cost of that Blob Storage, especially for 1 million records, is like nothing. Don't even care about it. I also know I can't run out If I start to run out, I just spin up another storage account and keep going without having to go through a big process at most organizations. So the other thing I want to show you, we can run queries, right? Everyone believes we can run SQL on top of files by using Azure Databricks. There's a few other ways to do it. You could use HD Insight, but we're just going to stick with Azure Databricks for now. The other thing I want to show you is that with SQL, you can create tables on top of these files. This query on the screen now is an example of schema on read. So we have this command, this statement in our create command called external. If you're new to this, external means leave the files where they are, format it as they are, like literally don't move them or reorganize them at all, and just put this schema on top of it. If my schema's right, there's a good chance, or if my schema's a little bit off, there's a good chance it acts like everything's fine, and then I query it, and it just all blows up because I've created a bad schema. It's a little bit different world than when we're structuring it, loading it to a database, and getting those error messages right away that we're breaking these constraints we have. We're also not going to have our unique constraints and things like that, which kind of helped us not load bad data. We're responsible more so to keep the data in the state it's supposed to be in. If it's raw, we know there's going to be duplicates. We expect there's going to be duplicates. We're going to have to deal with that somewhere along the processing. But if we're telling everyone this is a clean table, we've got to deal with that and make it happen. Yes, sir? Yes, good point. So down here on line 31, we are pointing to a folder. You are normally pointing to a folder that actually has quite a few files in it. And I'll actually show you some of the data, the way we store it in a little bit. Yes?
Is that pretty much the same as the PolyBase external table, or is it?
This is going to be better to continue to query than PolyBase. If you're trying to load to at least, so I've worked with the SQLDW version of PolyBase. If you're trying to grab a bunch of data from Blob Storage or some kind of storage system and load it into SQLDW, super helpful. Or sorry, Synapse Analytics, we'll talk about that soon. If you're trying to do that, it's super helpful to use PolyBase. If I want to get the top 100 records with PolyBase, my experience has been you're going to wait minutes, not seconds. So the syntax is going to be similar, yeah. This is actually the Hive syntax we're looking at. I might have a couple Databricks-specific things in these notebooks, but that's actually a Hive create statement. Hive is a way to run SQL on top of Hadoop. So you write this SQL, it gets translated into MapReduce, runs on Hadoop. Not the purpose of today's conversation, but just kind of all these things have sort of evolved on top of each other in a way, and they're sharing some of the libraries. It's actually, I think this uses the Hive Metastore by default. A lot of times with Spark, we're using the Hive Metastore behind the scenes. Does that help? That's been my experience. I want PolyBase to do this as fast as I experienced with Databricks. I haven't seen that yet, but I'm happy to hear otherwise. So basically, all right, one more cool Databricks feature, and I think we're going to get back to our slides. Two more things for you. The one I'm running right now is doing a bin of duration to show me how long each song is in minutes and rounding it down or rounding it up. And then I'm doing a average of song hotness, which is just such a great attribute. I had to use it in a demo. And then in Databricks work, if you've used notebooks, other places you've probably seen stuff like this, I can just click over and get like a simple bar chart of what's going on. The other thing you can do that's a little more advanced, you can switch over to Python mode and like do plotting with Python and do all kinds of stuff once you get the hang of it. So our notebook is more than just SQL, and we'll see a little bit more of that as I demo ADLS Gen 2 pretty soon. The final thing I'll call out, we don't really need to run it, is that you can create temporary views here. So much like a temp table in SQL Server, it's going to last for the duration of the session. And so I can get this all set up and ready to go and have Databricks create a table that I can then query. And then as soon as I kill my notebook, it's gone. Nothing too scary, right? Is anyone scared of this? All right. That's bold to raise your hand. I appreciate that. So moving back to the other things I want to discuss. Some best practices for data lakes. And Seems like there might be about half the people in this room that either will benefit from this or disagree with me because you've been doing this stuff, and that's good. If you're new, then take it, think about it. If you get on these projects, remember, hey, that one guy said this that one time at that one conference, and see if it helps you. So a metadata portal becomes more important here. Data discovery is this thing that I've talked about my whole career and hardly ever implemented. And what I expect is that, or no, what I've seen is that when we get into data lakes, not only do we have the problem of having way too many tables, so to speak, we now have a whole file system there, and we may or may not have access to all of the files in that file system that we should. It's a lot harder to make sure that the marketing analyst gets access to all of the data that should apply to the marketing analyst. And so if we start to actually document some of this stuff like we always talk about in most of the organizations I've been at, don't do it to the extent they should have, then we really start to benefit from all this data we're accumulating and have less problem of a data lake where we're not only storing more data than we need, like I've said, I think you should store more than you need, but we should at least know it's there so we can use it when it's time, right? Okay. Not just raw data. I think I've said that enough. We'll see. I might bring it up again. Data set certification. So because I say we're going to store a bunch of raw data, and I want you to store some of the more clean, usable, analyst-ready data, we got to have a way to indicate what is ready for analysts to use and what isn't. The more we can let people know, hey, if you build numbers that the CFO sees, they're going to compare it to this data set to see if you're right, the better off they'll be, the better you'll work together as an analytics and data science group. And not too much governance. So not too much governance means you got to give people access to the data. I would recommend having a set of default tables that anyone that gets access to the data lake goes through at least an hour, if not 2 days of training on what it means to have access to data, and they understand that there's some information in here that's company confidential, not highly sensitive, not going to mess up our customers' lives, but company confidential, and you're expected to respect it. Or if you really don't want to give that much power to people that you trust to do your analytics, then at least anonymize, secure the data in a way where there's a whole lot of data that as soon as you say, I've been trained on data lake, I'm ready to go, give them access to it. A JIRA ticket that sits for a week before you get access to data in a data lake is not the way to do it. So, Azure Blob Storage. What is a blob? A blob is a file. I learned that yesterday. Think of a blob as a file. Sometimes it's a VM, right? But a VM disk, but normally it's a file. So when we're talking about Azure Blob Storage, if you've worked with the other cloud providers, S3 is AWS's, which stands for Simple Storage Service, which is more confusing than Blob Storage in case you don't like the name. Google Cloud Platform has Google Cloud Storage, which is the best named one I've heard of. That's great. And what we're going to do is load up a bunch of data into the cloud, and they're going to store it for me in a distributed, redundant, unlikely to lose my data fashion. Almost always available. If I want it to be more available, I can check some boxes, pay more money, and it's going to always be available. So the other thing to know is that on the Yelp $1 to $4 scale, this is like a 1, because this is super cheap. And we'll look at the cost in a bit. I updated it all yesterday because it changed since I last made the slides. But they're at least good for today, I think. The blob storage setup, which is actually going to play into when we talk about ADLS storage in a second, we have a storage account. Guessing, it seems like we got some data lake people in here. So you've probably done this in Azure with blob storage, but let's go with it. Storage account is your organization of file systems. It's like your root directory, I guess, is the way I think about it. And I like to manage my permissions at the storage account if possible. But within the storage account, as soon as I create a storage account, let's say we create our marketing raw data storage account to be part of our data lake. I would then create a container, which might be our marketing analytics team or our CFO data, CMO data, that kind of stuff. Create those as containers, and then from there you're throwing blobs in there. You're throwing files in there. These files have a path. The path looks like a directory structure. You can reference it like a directory structure. It's not exactly a directory structure. When we're talking data lakes, though, it seems like Azure makes this simple for us. They have something called Azure Data Lake Storage. So I was like, boom, session's done. We know this. We know what to do for data lakes. But they have Gen 1 and Gen 2, which at first had me going, this is confusing. But one of them is called Gen 2, which means it's probably the one we want to be using because it's Gen 2 and not Gen 1. Here's the big difference that I see. ADLS Gen 1 is its own service. It's not part of Azure Blob Storage. ADLS Gen 2 is built on top of Azure Blob Storage. A lot of the APIs will interact between either of them. We'll see some Spark commands where we're switching like two things in the configs and we're hitting Blob Storage versus ADLS Gen 2. But it's got these benefits of ADLS Gen 1, other than some of the compatibility, unless they've already caught up. But some of the compatibility that ADLS Gen 1 has is not covered by ADLS Gen 2. But for my money, if I'm starting fresh, I'm moving to Gen 2. I'm building it there. If Microsoft wants me to use these other tools, they'll make them compatible with ADLS Gen 2. That's my thought on it. So it has the benefits of Gen 1, which is more scalability than standard blob storage, more granular security than standard blob storage. I'm going to say blob storage a lot today, guys. All right, and then file system semantics, which are beneficial. It's also a lower cost than ADLS Gen 1, which is another reason to go that path. It's really comparable to blob storage for a lot of use cases, I think. And then it's a hierarchical namespace, which means instead of having, we'll get there, sorry. So it's built on top of Azure Blob Storage. It's also got Hadoop compatible access, which means these Hadoop APIs that I said Spark's actually using and other systems are actually using to do big data stuff, even though they're not Hadoop, those are going to work with ADLS Gen 2 very well. It is optimized for cloud analytics, which is what we're talking about doing. So you're going to pay a little bit more depending on how many transactions you're running on this data, but you're going to get something optimized for the kind of work we're doing in a data lake. I am not strongly sold that blob storage is a bad idea and I need to move all my stuff right away, but it seems like the right fit going forward, and I'll show you interacting with it a little bit more here. So in this, we're basically just changing a few names that sometimes the UI doesn't even change for us. So we still have storage accounts. When you create your storage account, you have to pick between blob storage, there's some other options, but blob storage or ADLS Gen 2. Once we do that, instead of a container as the top level, we're going to create a file system. Doesn't really mean much for what you're doing. And then within that, we're going to put files, and there actually is more of a directory path. So they both look like they're in this nice directory structure. ADLS Gen 2 actually takes some advantage of like moving, deleting folders of data. So exactly how we move this data around is what Simon's going to cover tomorrow in his session. But in general, to get data into ADLS Gen 2, some of the main ways we would do that, Azure Databricks, which I'm showing you. I'm going to be able to do pretty much everything I'm talking about with that. Azure Data Factory, which I'm sure you've heard of by now. If not, go to Simon's session, hear more about the kind of ETL tool. It's ETL tool is kind of the wave of the future, I think, though I'm still trying to figure out exactly how much of SSIS is going to take over. AZ Copy is more of a command line tool. Some of the UI stuff will use it behind the scenes. And I've found like if I'm doing less than a terabyte of data, that can move data from one place to another. That's usually like local or VM, not so much cloud to cloud so far. And then Azure Storage Explorer is a UI that we can leverage to move this data. To get data back out, you can use Azure Databricks. You can use HD Insight, which is Hadoop and Spark. You can use Polybase from on-premise SQL Server Managed Instance, SQLDW. And we can also access it directly from PowerBI, which is going to be smaller data sets, but if you want to import like a chunk of the data, that's a way to access the data as well. So I want to show the setup steps, which is really quick. It's just kind of drag and we're not going to script this out like we would in the real world. We're just going to click on the UI, see the options we have, and talk about the really important ones. And then I'll show you what Storage Explorer uploading a file looks like, just so we can kind of see our directory structure, because we haven't really seen these files yet. We've queried them, but we haven't seen them. Any questions on what a data lake is? So I'm about to stop talking about data lakes for a little bit. Good. All right, let's see if my Databricks cluster is ready for me. So I'm moving over to just a different notebook here. Nope. I'm moving over to a different notebook here. The first thing the first thing I want to show you is how we can just mount these Blob Storage accounts or paths to our Databricks workspace. And so I'm not going to run it all, but if we look at lines 1 through 26 here, let me help you people in the back out a little bit, hopefully. It might be too big for me, but we'll see what happens. So we've got a function here that's going to mount an ADLS environment for my whole Databricks workspace. With the way this one's set up, once I do that, it's available to everyone that has access to my Databricks workspace, which means they might be working from a separate cluster in the workspace. They have their own compute, basically, but they now have this mounted drive. And so a few things to note. You can come back and follow along later. I'll post this code pretty soon here. I don't think I have to clean up too much stuff to be able to post it on my site. The one thing to know is we are not using clear text passwords. We shouldn't be doing that no matter what. The cool thing is that Databricks gives us this secrets thing. So we can do dbutils.secrets.get and reference a secret scope that we set up. In this case, it's actually pointing, this one I think is pointing to Azure Key Vault behind the scenes, pulling out secrets. Ike's going to demo that at the 10 cool things about Databricks tomorrow if you want to see a little more about how we set that up. But basically, I followed some docs. I got my secrets set up. Took a little bit longer than pretty much anything else in this section. Built my configs, which I got from the docs. I didn't make this up. I don't really understand a lot of this. I just looked at the docs, translated it to what my information. And then I called the mount dbfs utils fs mount command. And the things I want you to know so that you know what the heck's going on in all these statements I show you is ABFSS is representing Azure Data Lake Storage Gen 2. Down here, a little further down in line 34, I am accessing Blob Storage with WASBS. And the configs are a little different and simpler for Blob Storage. The thing I'm mapping to, just so we can all keep tabs on what's happening today, I'm mounting to MNT ADLS demo for ADLS, MNT blob demo for blob. And what this enables is that I can now reference MNT ADLS demo all over the place and not have to do all of my credentials every time, not have to paste that whole ADLS ABFSS path, which I tend to get wrong the first time I do it. I have this like shortcut, right? I have this mounted folder is all it is. Databricks gives us these magic commands that start with a %sign. This one lets us see the data that's in a certain part of my ADLS bucket. So I actually don't need to run that. You saw the results. You can tell it worked. The thing I want to show you is that for this New York taxi data set, this is an example of how I would organize data in a data lake. We have kind of our container, our file system in this case. We have some type of organizational structure. In this case, all my New York taxi data is going to go under it. Then I have what's my table name. Yellow Trips is my table name. And then I have partitions. We aren't going to go in depth on partitions, but I need to take a moment to say, if you're doing data lake stuff, partitions are going to be important. You used to spend your time worrying about indexes. You're going to spend your time worrying about partitions, most likely. This format here is the field name equals value, and that's what Spark and Hive speak really well. Most tools I've come across interpret that one better than most ways. And so this is actually what we have. And as was pointed out earlier, this is a path, not a file. Let's see, I think this will play along with me and show us that there's, it's a little messy today, but there's actually quite a few files under here, and they're all, I think, about 30 megs in size, I believe, which actually might be a little small, but we do like to break the data up into chunks. Part of the reason the data shows up in multiple files is because when I process with Spark, it's distributed. There's 2 worker nodes running. In my case, there was probably about 8 tasks running in parallel on this system, and each of them was writing directly to ADLS Gen 2 themselves. So we didn't want to spend the time to collect it all back up into one application, put it all together, and save it as one big file. Having too small of files, so the question is there performance benefits one way or another? Having too small of files will give you a performance hit. You do not want too small of files. with Spark, I struggle a little bit. With Hadoop, it was always, you want your file to be at least 128 megs or 256 megs, whatever your page block size was. And with Spark, I found, if you're getting 30 meg, 100 meg files, you're probably in pretty good shape. Any other questions at this point? All right, the thing I want to make sure you know right now is that we are leveraging Spark to query a data lake directly on top of ADLS Gen 2. The other thing I want to take just a couple minutes to show is we have, is basically what Spark code looks like to read this data. So if you don't want to use SQL, or you want to do things that are more advanced and a little bit tricky to do in SQL, which is really how I ended up on this path, you can read in a table pretty easily, copy and paste this type of command all over the place. So in line 1 here, I am setting a file location variable in Python, nothing special, just a path. And then here is where I have a command I could take and use all over the place. It's Spark, which is my Spark session behind the scenes, .read.parquet. Parquet is a file format. You could do read CSV. There's just a bunch more options that go along with it. Parquet is going to be better performing for a lot of analytics workloads. And so I do Spark read Parquet. My data is stored as Parquet files. They all have a schema with them. That's the way Parquet works. They're all nicely compressed, which gives me some of those performance benefits. And I now have data. I guess we can watch that thing run, huh? So when I run this, and I'm basically doing the show command right here is just a head. So it's going to show the first 20, I think. And of course, we're printing it to console, so it's not the prettiest thing. But you can see we just pulled top 20 records in 2 seconds. So I can do that. I don't have to go get coffee in between. Yes?
Do you have to declare variables?
The question is, do you have to declare variables? No. You just say, this is my variable name, this is what it equals, and it's going to figure out the type based on yeah. This is Python. If you do it in Scala, which is, okay, so the languages we tend to use are Python and Scala as data engineers working with Spark and Databricks. Some of us use Java, and some people will use R and Spark R to do this kind of work. And I mean that specifically to when you're working with Spark. When you're not working with Spark, a lot of data engineers still tend to use Python and Scala, but the options open up more because there's more things. You can do data engineering with a lot of languages, but these are the ones that are most heavily invested in and suited for data engineering workloads. Yes?
You use the wildcard up there on your library.
I meant to call that out. Yeah, you want to hear about that? Oh, wait, where did I do it? Yes. I did use a wildcard here. When you're creating the table, you specify a folder, and it's just going to understand that everything in that folder is what you want. When you're reading a path, when you're reading it this way with the Spark APIs, I believe the wildcard's required. Does that sound right? Or am I wrong? I tend to do the wildcard. Let's see. Let's run this guy without it. Where'd it go? All right, so the wildcard is optional. A lot of times what I'm doing is things like this, which is not very SQL-like, but works really well with Spark. You just say, hey, I want everything in 2018, or I want everything that's, I don't know. I want everything, whatever, you get the idea. So like a lot of times I use wildcards, and so I think I'm just in the habit of doing it every time. So thanks for calling that out. That wildcard is optional. One more thing to show in Spark, then let's get back to talking so we make sure we have plenty of time for data warehouses, is another thing we can do is a filter. And what I want you to see here is simply that I reference my data first. I can then do transformations on it, such as a filter. I'm basically giving it a column name using this betweens clause, so just the dates between January and December 2018. And Spark is going to basically put this all together, optimize it as a query, so to speak, and run it, and then return the results when I do something like a show or a count or something that causes it to run. So I kind of build all these pieces together as I go. And so you can end up writing code that you just kind of learn piece by piece as you go. couple, yeah.
So when you do the Spark piece, is it turning into a regular Python data frame, or is it a specific type? So could you use like tidyverse or some of the other tools
It's,
to mess with the data frame other than that?
so I'm reading it in as a Spark data frame. So the Spark, so the question was kind of, is it a Spark-specific data frame? Can you use it with tidyverse and other things? So I'm reading it as a Spark data frame. There's some support to convert to other tools. I've converted to pandas a bit. I think it's just like 2 pandas or something like that once it's built.
And then you can use all the pandas stuff on them.
Yeah, I've done way more often the opposite. I've created it with pandas and then converted to Spark for all of the transformations and more hardcore stuff. But if you're going to filter, that might be a reason. I haven't really experimented with like the differences in performance there, but reading a bunch of data and filtering it and all that with Spark might be a good start to get some of that predicate pushed down that it should be doing for you. So the other thing that we will look at before we move on to other storage types is just what it looks like to create a storage account. So this is the Azure portal. Thankfully, everything I use is up at the top for me, so I can just click on storage account, click the add button, zoom in my screen for you all. Maybe, will it let me? There we go. And a lot of this isn't really worth getting into. You have to pick a resource group. You have to pick a name, of course. But the things I wanted to show off a little bit is that you probably, for data lake stuff, at least my experience with data lake stuff, we're going to stick with standard, stick with storage v2. We're going to think about replication if this is production data. If it's dev, if you're playing around, we're going to stick with locally redundant storage. We're probably going to start off with hot storage and eventually start to look at our bill, figure out what data no one's touching, and move that to cool storage. And then we want to move on to the next step. I missed what I was looking for. What did I miss? There we go. You want to go to the Advanced tab. That normally just happens for me. I'm not sure what I'm doing differently during demo time. On the Advanced tab, you'll of course want to keep secure transfer checked. Think about the other options, but then here's where we can switch to Data Lake Storage Gen 2. So I told you it's at the storage account. This is where you set it. There's 2 names basically, hierarchical namespace, Data Lake Storage Gen 2. I've seen it do a pretty good job of using both names together a lot of times. So it makes it a little simpler for us to know what to choose. So that's pretty much all I normally set up. Configure the thing and you're good to go. And then just a quick example of how I normally would interact with it for demo stuff like this, when I can download the data from the internet and upload it manually, is I'll use this Azure Storage Explorer tool. You just kind of sign into your Microsoft account when you open it up. You can see all your storage accounts. The one I'm working with today is DV Training ADLS. And then I can click on Blob Containers, which is really a file system. I can click on my file system name. And in this case, I'm actually in a specific folder. I can see there's quite a few folders here. And then I can simply click the upload button, upload a file as if it's most UIs for dealing with files. So this is a really easy way to deal with like your local test, whatever data that you happen to have locally that's going to go into your ADLS environment. For all of the more realistic stuff, that's where I think Simon Session is going to come in handy to understand what we would do. Any questions at this point? Yes.
So what you were doing in Databricks, are you able to do that in blob storage too, or just?
Yeah, I don't think so what I was doing with ADLS from Databricks, I can do with Blob Storage, yes.
So you can partition in both?
Yeah, exactly. So you can do the same stuff with Blob and ADLS from Databricks. So all this stuff I'm showing you would work for both. And we can partition also, which was the last part of that question.
So question, on the data lake, how do you organize your folder structure in terms of data, clean data, raw data, all that?
Yeah, I think there's a good chance you have different storage accounts for those. You may not though, but basically you probably have some kind of naming convention you use. Like I would probably have a top level, whatever the top level one's gonna look at would have things like user data raw, sales data raw, something like that. That's this big bucket. Like anything though, when you're doing this with databases, you get, and with databases and schemas, you get into this, well, it kind of fits both areas, so it's kind of up to your organization to figure it out. I've seen some of the bigger implementations I've seen, it's kind of organized by source team. So if the marketing analytics team is the one that creates it, it goes in their structure. And then as far as the table names or any kind of organization they want to do underneath that top level, that's up to the team to try and do, or you come up with standards in it with it, just like you would shared folder systems. Is that it?
Just under one storage account, right? Or do you do like different storage accounts?
The question is whether we do one storage account or multiple. I think you probably do multiple. I would do multiple, is the way I would typically go about it. Yes?
A little bit confused about the security paradigm for generation 2. I saw you earlier create a mount point in Python, I think it was, and you used a username and a secret. And I also saw you create a storage account for that file system.
Mm-hmm.
And you said that in Gen 1 it was a container versus Gen 2 it was a file system. So is there an association between the secret for the mount point and the storage account that you want to connect to? Or are they two separate things? Am I just totally off base?
So yeah, the question is basically how are we doing security? I was mounting data with using some secret info. Was that tied back to the ADLS storage account I was dealing with? In that case, I'm pretty sure I created a service principal. So there's a pretty good documentation section about this in the Azure Databricks docs. In that case, I think I followed the model where I created a service principal, associated that with the storage account and assigned access, found all the different properties that are scattered around the properties screen with different names and Databricks uses, and then translated those into my config. So I can try and follow up with more information on Twitter about what that looks like, because it's a little bit tricky, but the Azure Databricks docs kind of walk you through that, and with a little bit of banging your head against the difference in names. It's pretty straightforward once you get the name mapping correct. But there's a service principal account I created in Azure. I associated that with permissions to that whole Blob Storage account or container. I forget the level I had to set it at. And then once I attach it to the workspace, other people may not know about that service principal and the credentials I used, but they now have access to that data because I mounted it to the whole workspace.
Is the service account credential the same as the storage account credential? Or are they different?
Most of the time I'm accessing I'm accessing the storage account as myself, as my own Azure Active Directory user. The service principal that I'm using to tie that security in is its own thing. You can search for service principal, and in the docs when it says service principal, it'll help kind of translate all this to what you actually have to click on in Azure. So definitely feel free to follow up if you're wanting like step-by-step how I did that. The security is not too tricky, but it's a little tricky in my opinion. All right, let's keep on moving here. You might want to consider archive storage. It's going to be cheaper to store, more expensive to read, and if you try and delete it right away, you get charged fees for it. So kind of like your mutual funds or something, you kind of invest in it, try to forget about it, and check it every once in a while to see what to do next. So cost comparison, what I want you to get out of this is that these are the prices today. There's actually a little bit more complexity than this, but these are basically the prices today. We're looking at hot blob storage versus hot ADLS Gen 2. So the storage per gig per month is exactly the same. About 2 pennies, about 2 cents per gig per month for both of them. When you start talking about reads and writes, you pay a little bit more for reads and a little bit more for writes per 10,000 transactions for Azure Data Lake Storage Gen 2, right? So we're paying more to access and leverage this data. Also, the way they talk about transactions starts to care about how much data you're working with ADLS Gen 2. So if my recommendation is, like, if you're trying to figure this out if the cost is a problem, run some numbers using pretty basic stuff like this. Just saying, oh, I think it's about this many transactions that we're going to deal with, and see what that cost is on a smaller data set than the full thing, kind of get a feel of what you're actually getting billed, and then extrapolate from there. In the docs, they have this like example walkthrough of if you do this, and then here's what your monthly bill looks like. I honestly didn't have time to understand that whole thing. It takes a little sitting and thinking. So run some projections, of course, but I think you're going to need to worry way more about your compute, your Databricks workspace, your other things you're standing up than the storage cost. Well, than the difference between Blob Storage and ADLS Gen 2 storage costs, especially. When you get into cool mode, again, the storage cost is the same. The reads and writes go, the thing I need you to see here is that the reads and writes actually go up when you go to cool, which might sound obvious, but that's the idea. You're paying less to store it, more to access it. When you get to archive, you really want to look into what's the right way to get this data out of archive, because the read transactions, these are dollars under the reads transactions. So look into the right way to use archive storage if you're going to start using it. But the storage is like a tenth of what it is for hot. So you're going to save quite a bit on storage if you really don't think you're using this data very often.
So maybe comment,
Yes?
you cannot read data from archive. You have to move it either to cool or hot, right? There's also a transfer charge every time you do that.
Okay, so the comment was that his understanding is that you cannot read directly from archive storage. You have to move it, unarchive it, right?
You have to move it from archive to cool or hot, and there's a transfer fee every time.
And there's a transfer fee.
You move it back.
I'm not entirely sure. The docs have read transactions in there, and I didn't want to test it, honestly. Yeah?
So hot, cold, and archive is all within like one storage account? Like, is it per individual blob that you can set, or how does that work?
I see it at the storage account level. No, you can set it in more detail than the storage account level. Is that for hot and cool storage? Do you know, Ike?
Yeah, well, so my understanding is that the feature they just released recently is that you can change hot and cold without the URI to the file changing. So that allows you to know where your data is and build tooling on it and then determine pricing later.
And so if that's the case, so you're saying that we can change it with hot and cool storage, we can change whether it's hot or cool without the URI changing. I've seen the option at the storage account level. I don't know if you have to move a whole storage account at a time. I don't think you do, but it's not something I do regularly. Cool. Ike Ellis, follow him on Twitter. He'll get you the answer. I'll retweet it too, so we'll get there. Storage redundancy, this is really for reference. Think about storage redundancy before you go to production. Someone will probably tell you that anyway, but I got to do my due diligence. That, and I'm not responsible for any cost you incur trying out these demos at home. Those are the two things you need to know. I'm not giving you every bit of detailed information you need to think about for your organization. We probably all know that. And be very careful about what you spin up, because this stuff can add up, especially what I'm about to possibly demo, at least talk about. So we're going to talk about data warehouses. Let me keep moving a little bit, and then I definitely will have time to stand around and take questions at the end. Data warehouse, I think we know better. Here's the definition I want to use for this conversation. A data warehouse is structured data, and by that I'm really not so much talking about the format, but that it's processed and modeled for analytics use. It's ready to go data. It's going to support interactive queries. Analysts can get answers to questions quickly, hopefully not taking minutes to get them answers to questions that are pretty normal questions to ask. I know it's not how it always goes, but 90%, probably more, are pretty quick. And we're going to have BI tool support. So our Power BI, our Tableau, whatever we're using, is probably going to connect directly to that data warehouse, possibly do some importing depending on the setup. So the reasons for this might be obvious, but one of the main reasons I see data warehouses being really effective still. And by data warehouse, note I didn't say you're following the Kimball methodology and you have every bit of data that any analyst is going to use in there. I kind of kept it a little broader than that so that you can kind of decide what this means as I talk about what I think we're trying to get out of them. And if our data lake's not delivering it to the people it needs to deliver it to, then the data warehouse or some other analytic data solution that looks a lot like one starts to become relevant. So speed of thought, we want our analysts, our decision makers to think, ask, get answers, make decisions, not think, figure out how to ask it, sit there and wait, go get coffee, forget they asked the question. You know how it goes. We want our data to be ready to use. Good column names, clean and standardized. Hopefully we've talked to some people in the business before we built the thing. We want to do updates and deletes, and this is changing. I mean, these systems are changing all the time, and so there's something called Delta Lake that works with Databricks that I'm starting to use to do updates and deletes more often than I would have in the past. But a lot of times with data warehouses, I end up putting stuff into a data warehouse solution because I need to stream data in and do upserts. I need to insert or update things that already existed because they've just changed. And then some best practices. I still think these are valid despite the changes, right? And so I still think you want to keep your staging data off limits. People have access to these data marts that are kind of star schema design, ready to go, hopefully easy to use. All the stuff you're doing along the way, that intermediate data I talked about you should put in your data lake, they don't get it from your staging area. The reason is because the types of systems we are using to build these typically are relational databases, and if they're hitting your staging data at night or you're changing your staging data to improve your data warehouse, you break a bunch of really important stuff. You might get woken up at 3 a.m. because your table's locked. Like all these things that kind of are tough to deal with, we avoid some of it by limiting who can access staging data. We're going to have to think about indexing strategies, of course, and we're probably going to think about read replicas to try and split up our write and read, especially going forward as we start to load not just once a night. Probably a lot of us are already getting there. We're not loading once a night anymore. We don't have this 8-hour window. We probably still have some really big batch stuff we do, but we also have some stuff we're doing pretty frequently. So the place I would start, the place I would want to build this, if possible, in Azure is Azure SQL DB. That's kind of a broad term, actually. We'll talk a little bit more there. It's a relational database, but it's managed by Azure. It's a PaaS offering, and so I don't have to worry about patching, OS upgrades, those kind of things. Even the SQL Server upgrade, they'll take care of for me when I'm going this path. And you can make that fairly inexpensive or really expensive. It's more than I want it to be, but it's really not too bad for a database. One of the ways to implement these is using elastic pools. Elastic pools are similar to what a SQL Server on-premise would be, I guess, where you have this shared resources and shared environment to an extent. You're basically saying, I want all of this CPU and all of this storage in my elastic pool. I'm going to put multiple databases there. My databases aren't going to be talking cross-database most likely. It's not really kind of the built-in way to do it. My databases will each be in that pool. And the reason I want to do this is some of them have peaks at certain times and some of them have peaks at different times. And as I scale, I just want to drag the slider on one elastic pool and then say how much each database is allowed to use of that pool. So you need to understand your peak usage and DB utilization to really get benefits out of this, I think. Though it might be a way to get a little sandbox where you have the compute and storage fixed, but your team's allowed to actually create databases and recreate them when you want. So it might be a way to kind of give yourself a little bit of sandbox space and still be able to create your own databases. SQL DB managed instances are typically going to be used when you're trying to migrate, and there's features Azure SQL DB does not support that you want to use. So SQL Agent would be a good one that you may want to keep using the way you've been using it. CLR, there's some restrictions on what's considered safe, so you can't do unsafe things to the OS especially. But basically what's going to happen is Azure spins up a VM for you, manages SQL Server on it. You're not dealing with the patching. You're not dealing with some of that OS stuff. You also can't log into it and install extra stuff with it. If you need to install SSIS and SSRS or other tools on the same server because you've been doing that for years and you can't get away from it, that's where you'd probably start with a VM that you install SQL Server on yourself. Go that path and then try and move to these other options. So Azure SQL DB Hyperscale. Let's see how fast we can talk about Hyperscale. So I think most everyone saw the keynote and you know this thing's amazing. This is a big deal. So what Hyperscale is going to give us is the ability to be scaling transactional systems horizontally, which is something we've been struggling with forever. I'm very excited because this storage, compute, and log separation, where you can scale them separately, and the way they're doing their logging in particular, has been really helpful when we want to write a whole bunch of data as fast as possible to the database. It's also very valuable if you want to do fast backups of really large data sets. It's just a whole different ballgame because of that separation of compute scaling, the way they've implemented it to be able to fail over, and some of the things you'll be doing will actually be kind of scaling and then swapping behind the scenes, which certainly can be done on premise, but it takes a lot more work on your ops people. And it is optimized for transactions. So it's going to be really useful in the transactional world. I think it's going to be really useful in the analytical world if you've got the usage and the data to justify the cost of this. Once you go to hyperscale with your Azure SQL DB, you're not coming back. So you can go to business critical, which is one of the better performing tiers, and you can bounce back to general purpose. Once you go to hyperscale, you've made the leap and you're there. You'd have to like re-script out all your data and database and all that stuff. So again, you're responsible for that part. I won't go deep on the hyperscale architecture, but the really cool thing, I think, is that idea of storage and compute separation is happening here. You probably pay more for it than I'm picturing when I talk about that compute separation, but they're taking the storage engine of SQL Server and they're breaking it into this page server microservice architecture. We have multiple page servers. I think it's 128 gigs each they hold with their own SSD cache, and you can put a whole bunch of data in there and have your compute start off a bit small. There is some relationship between compute and storage, at least the last time I tried to, that actually might have gone away like this week. There's basically the ability to have a whole bunch of data and not pay for a crazy amount of compute just because it took a lot of compute to load it. Does that make sense? Maybe? Okay. I have some references for you if you want to hear more about that. There's at least one presentation that I think is going to dive deeper.
So just one example of scale. So we were able to take our Azure SQL Data Warehouse. So we had a star schema in there and put that on Hyperscale and get the same performance but higher concurrency because it's database, not the MPP. The only so we're talking a terabyte or so of data, not terabytes and not petabytes. So for small sets of data, I can't vouch for anything bigger than this, but small sets of data, we actually got the same performance from Hyperscale than we were getting from the data warehouse. And it's a much
Do you know the cost savings roughly, percentage-wise? Half?
At least.
Okay.
Because it's part of the vCore solution, you're able to use the hybrid benefits cost model.
Okay.
And you're able to get some hybrid benefits out of that, which SQL Data Warehouse does not.
And that means you bring your own license, right? When we're talking hybrid benefit. Okay. So let me thank you. He said something I was actually thinking I would say, and I just kind of backed away from, but he's done it, or he's seen it. So for a terabyte-sized data store, they were using SQL DW. It was performing pretty well, but you're having concurrency issues. Was that the deal?
Yes. So
Okay. And it's expensive, which I think we know.
If you have a lower tier, so say 500,
Uh-huh.
right, you're limited to like 20 concurrent queries.
Okay. All right.
Versus Hyperscale, your concurrency is not an issue.
Okay, cool. So they had some limitations on concurrency that was starting to be an issue. Obviously, there's a cost factor with Synapse Analytics or SQL Data Warehouse. And they were able to switch to Hyperscale with that terabyte-sized data and get better performance, same performance, better concurrency, at least half the cost savings, though they were able to use the hybrid benefit, which is bring your own licenses to the cloud, and definitely something to check in. If you're standing this stuff up and you've got licenses at your company, take a look at that because you don't want to double pay for licenses.
So actually, I said the same. I'm going to say better because we don't have concurrency issues.
Okay.
The concurrency issues, my queries would sit there in the queue and wait
Yeah.
and not even execute.
Cool.
So, taking that away, obviously, it was a better performance.
All right, and that's an analytics. Yeah, it's analytics workload because you're doing it in SQL DW. Cool.
PowerBI direct query right on top of it.
All right. So we got a real world example of Hyperscale replacing SQL DW, which we might see happen. Though, on that note, Synapse Analytics, or SQLDW, you'll see both names in the UI still. Actually, you may not see Synapse Analytics that often in the UI yet. But this is SQLDW. It's the next gen of SQLDW. But what they're starting to do is put more and more of the functionality as part of the platform. So when I go, I might have time to show you, but basically what you need to know is that when I go there, when I go to my SQLDW environment, I have a spot that says load data. I have a spot that says visualize data. If I click there, it's going to open up Azure Data Factory or Power BI service. It can let me set it up along the way if I'm new to it, and just start to integrate this stuff around SQLDW. The cost of this is high, and I'm hopeful, I don't know about hopeful, I would like, with the vision that they have, that sounds amazing to me, to see the cost go down to where it's more accessible to more people, but it is a very powerful, massive parallel processing system. So it's doing a whole bunch of stuff in parallel, fast reads. My understanding is many users, but you have to pay for a certain workload to get the current concurrency I'm picturing, it sounds like. So that's a good reminder there. And you can scale it up and down. You can pause the compute. You're paying quite a bit for storage, but as long as you're storing multiple terabytes, I don't think it's too crazy for storage. The compute's where it's going to add up, but you can pause it if you're not using it. I don't know if that's a realistic scenario, but that's, for me doing demos, that was nice because I was able to run some Polybase tests with it and then pause it. All right, we'll do one final look at a couple of things in Azure before we finish. Let me touch briefly on Cosmos DB. It's not something I use often for analytics, but the cases that I've heard of being the most useful are if you're trying to do in-app analytics for your customers. So let's say you're delivering customer reports, you're going to be doing a search on the customer ID each time to pull back that data. This is going to be something that Cosmos DB might be well suited for depending on the structure of the data. The other thing to know about Cosmos DB that you may have already heard many times is it supports all kinds of different APIs, so much that it gets a bit confusing. But we can use their SQL API and write something that's SQL-like to access their document store. And we can also use Graph, and Graph can come into analytics in some interesting scenarios when you're trying to deal with relationships. And so I've seen Graph databases be really powerful for doing fraud investigation when you're looking at link analysis between bad actors and all kinds of accounts and things. And so you might want to experiment with that. And then there's other cases, maybe key value would come into play for your analytics group. But certainly much more an application development tool typically. But when you're trying to do analytics in the app, I think you start to see some reasons to be using that. Let's talk about this. Then I'll show you what a Polybase query looks like to show that it almost looks like what I already showed you in Data Lake Analytics earlier. So Azure Analysis Services, you guys probably know what this is. It's basically the benefit it's going to give you is a shared semantic model. We can put this on top of the data that we're storing in these environments, and it can be a way to make it easier for people to get the data. We can build our aggregations into there and cache data for benefits. Power BI is a common way to access our data. And the main thing I want to tell you about that, I think I already kind of spilled the beans on, which is it can connect to Azure Data Lake Storage. I guess I haven't told you yet, it can connect to Azure Databricks. So let's actually look at that very briefly. Switch over to demo mode for the last time here. Cool. So this is Power BI. Oh, man. I can't even see that one. Let's see. Maybe. I think I went too much. I've lost control of everything. By the way, it's a good time to share that actually doing parallels in Windows VM on the Mac isn't too bad as long as you don't need a lot of CPU and memory resources. But sometimes the buttons get a little weird. So here's what I want to tell you, and I'll click buttons for those that are up close to see a little bit that I'm not completely lying here. What I've done is I've created these Spark SQL tables that I showed you how to create those in SQL statements. I showed you how to create those with, I kind of showed you how to create those with Spark. I guess I didn't actually do the save as table. I think I skimmed past that. I'm able to access those tables by creating a data source that is a Spark data source. And Ike is going to demo this tomorrow at our 10 Cool Things About Databricks. But the key thing to know if you go trying to do this at home, the URL you need is kind of tricky, so look at the docs quite a bit, make sure you get what they're doing when they piece it all together. And then the username is token, and the password is this Databricks API token that you create. It's pretty easy to find the docs on how to create that token, but just know that that's the password you're going to use. Token is the username we will all use to do it, at least this way I'm doing. I'm not sure what other options you have. But with that, in this case, I'm actually importing the data. So once I do that, I was able to, I'll just kind of show you from a pre-built one so we don't have to sit around waiting. With all that information, the server name, the protocol, I was able to then go and pick a table from all of my tables that are available to the cluster that I specified in my URL. Yes?
So does that mean the cluster has to be running in order for Power BI to pull the
Yeah.
data?
Yeah. I haven't tried if it'll turn it on for you. What's up?
I think it has to be, the cluster has to be running.
Okay, so we think the cluster has to be running already for Power BI to connect to it.
Because when the cluster is not running, you can't see any of the resources on your, even when you
Right, yeah. Okay, so we think the cluster has to be running for that to work, which probably means I'm not going to use it very often. But, it's cool. The other thing you can do is connect directly to Data Lake Gen 2. I recommend going to the site SQL Chick, Melissa Coates' old site, but I think it links to her new one where she just did a recent walkthrough of how to connect to ADLS Gen 2 if you want to see that in action. Just a couple of weird things you have to do. She documented it pretty well. One other piece I'll show you real briefly. Nothing too exciting about the database queries I had anyway, but I do want to show you what the external table query does. And this is back to the question earlier. The creation of the external table looks a lot like what I did from Databricks, but whoa. I got to learn the shortcuts in Azure Data Studio. But what I want you to see is when I run this query that takes like a couple seconds in SQLDW or Azure SQL Database with a couple of indexes on it, it's going to be about 5 minutes before I get this result using external tables with Polybase from SQLDW. But I can do it. I can take SQL Server, SQLDW, and reach out to my data lake storage and pull that data in. It's just going to be slower performing than I expect you're going to get from the Databricks workspace. If you have a different experience, please let me know, because this isn't something I do every day. I usually am in the data lake side of things or working with Azure SQL DB where I can't do this Polybase magic. So let me wrap this whole thing up, and then I'll hang around for questions. So before I give you my final thoughts, know that there is a slide that you can go to my Twitter, Dustin Vannoy, go to dustinvannoy.com and see my slide deck on SlideShare. These are all the things I looked through that are past sessions that have not happened yet. Let me expand that for you. Past sessions that have not happened yet that might be worth digging into if you're interested in learning more about some of these topics. I do not have the times for you because honestly it was quite hard to pull this list together before the session started. So hopefully that's helpful to some of you. Oh yeah, take photos if you want. This is really the last slide you need to see. Don't forget to do session evaluations. And then the other final thought I want to say to pull this all back together, it's probably obvious from the way I stated this, but I think data lakes are really powerful and going to be used quite a bit in the future for your organization, if not already. I do think data warehouses and analytic databases that are pretty much data warehouses without all the, all the uppity schema stuff that we argue about. I think those have a place because you saw the data lake analytics environment, right? Not everyone's going to be able to go there. We have to have the cluster always running for Power BI to hit there. We're probably going to import the data from the cluster anyway, and so having a direct connection to SQLDW might be the way to go if we are trying to query these things live from our reports. There's a lot of reasons that you're going to find, hey, the data lake's great. I can store a whole bunch of data. It's a little slower than I want when I'm trying to query it, or it's a little harder than my analysts are willing to deal with. But you're probably going to be hiring data scientists soon, if not already, that will love that they can go into a notebook environment, choose from Python, R, Spark, access this data and do stuff with it, and you haven't taken the time to clean it up for them because they probably don't want that anyway. So we're starting to see this world where I think the data warehouse is I don't think it's going to die, but we're probably gonna start saying it's dead like we do with Hadoop, right? I don't think it's dying, but we're gonna start doing more and more stuff in the data lake and decide not to spend the time to add it to our data warehouse at the end of the day. That is something you should argue with me about. You don't need to agree with that statement, but I don't think it's going away as the key thing to know. I also think you can learn all this stuff we did on the data lake side if you don't already know it. It's not that crazy. Just takes a little digging in, and it's actually pretty fun to work with once you get the right permissions and connections set up. So appreciate all your time. I'll hang out for questions. Enjoy the rest of Summit, and don't forget to check out our other data engineer path.